So today we're going to look at comparing and ordering decimals. We've done fractions and whole numbers, and now we're looking at decimals. So the first thing that we need to know about comparing and ordering decimals is we need to learn about their place value. So just like whole numbers have place value, decimals also have different place value columns. So in a whole number, we know that we have the ones column, the tens, the hundreds, thousands, 10,000s, 100,000s, and it just keeps on going. And these are all to the left of the decimal place. So if we look at an example here, this number reads as 15,308. So if I were to put that into a place value chart, the 1 is in the 10,000s column, so I'd put the 1 here under 10,000s. The 5 is in the thousands, so 5 in thousands, and so on. Just plug in the numbers into each of the place value spots. So if we wanted to compare that number, 15,308, with another number, like 14,999, if we just plug them both into a place value chart, it's really easy to compare them side by side. So what we would do, if we're going to compare whole numbers, to find out which one's larger or smaller, we want to start all the way to the left, because these represent the largest place value columns. So if one of these numbers are different in the largest place value column, then that will tell you right away that one number is bigger than another. So in these two examples, we have nothing in the hundred thousands column, so we'd move one spot to the right and compare these numbers. Now, there's a 1 in each of these. So in this respect, in the 10,000s column, they're equal so far. So we move one spot more to the right to the thousands column. So now here we have a difference. This number has a 5 in the thousands, and this has a 4 in the thousands. So that tells us right away that this first number is larger. We don't have to look at the rest of the digits because we know that 5,000 is always larger than 4,000. A common mistake here is at first glance, we see all these 9s, and so then we assume that maybe this number might be larger, or someone starts to look at the number from the right and go from right to left, you see these 9s and you think it's going to be larger. But you always want to start from the left and keep on working your way one column at a time to the right until you have a difference in numbers, and then whichever one is larger, well, that means that entire number will be larger than the other one. With a decimal, the further right you go, the smaller the place value. This is also true of whole numbers. The place values themselves sound very similar to the whole number side, with one exception. The first spot to the left of the decimal is the ones place value. The first spot to the right of the decimal is the tenths. There is no once. Besides this, they look and sound very similar. So we have the tens column, the tenths, the hundreds, the hundredths, the thousands, and the thousandths. The only difference is that you add the THS, see here, here, and here, onto the end of each place value. So to compare a decimal, we use the exact same rule as with whole numbers. We start on the left end here, down at the tenths column, and if you're comparing two different decimals, you look at the digits in the tenths column, and if one of them was different, if one of the digits was larger, then that means that that decimal, the entire decimal, is going to be larger. If they were the same, we'd use the same rule. We'd move one spot to the right and compare those place values. So and you'd keep on going down the place value chart until you found two digits that were different. And the one that was larger meant that the entire decimal would be larger. So here are some examples of comparing decimals. I have 0.2 and 0.1. So this reads as 2 tenths, and this is 1 tenth, because the 2 is in the tenths column, and the 1 is in the tenths column. Remember, the tenths place value column is one spot to the right of the decimal. So I just look at each of these digits. They're both in the tenths column. 2 is larger than 1, so that means this whole decimal, 2 tenths, is greater than 1 tenth. By reading it out loud, it's often easier to compare decimals, because if I just read this as 2 tenths, 1 tenth, well, yeah, 2 is larger than 1, so 2 tenths is larger than 1 tenth. The next example here, I have a 2 and a 1 again. However, the 2 is in a different place value. it's in the hundredths column. So this one reads as 200ths, and this decimal is the same, it's 1/10. So you might jump to the conclusion, well, 2 is larger than 1, so this decimal has to be larger. But remember, we want to start with the place value on the left side here. So this is the tenths column here, and this is the tenths column in this decimal. This decimal, there's a 1, and this decimal, there's a 0. Because 1's larger than 0, that means that this decimal is larger. So I can write it or read it as 200ths is less than 1/10. Because remember, a hundredth is a much smaller portion than a tenth. So just because I have 2 of these doesn't mean that it's greater. 200ths is still a very small amount compared to 1/10. The third comparison here, we have 8/10ths. The 8 is in the tenths column. And over here, it goes to the hundredths column. So this reads 25/100ths. And again, some people might think that, oh, well, this is 25. 25 is bigger than 8, so this decimal has to be larger. But you just want to look at it one place value at a time. So look at the tenths column. I have an 8 here, 8/10ths. In this tenths column, I have a 2, and 8 is larger than 2, so we don't even need to look at the 5 here. Because 8/10ths are larger than 2/10ths, then this decimal, 8/10ths, is going to be larger than or greater than 25/100ths, because the 8 is greater than 2. When we're comparing decimals, parts of wholes, we can also just plug them into a place value chart. It might make it a little easier to compare them, because just like with whole numbers, we can kind of move down the place values and they're stacked right on top of each other, so it's a little easier to see which decimal is bigger. If we want to compare these 4 decimals here, I've got 0.6 or 6/10ths, 0.05, that's 5/100ths, 0.001, that's 1/1000th, and 0.4, 4/10ths. We can put them in the place value chart like this. So we just plug them in. They all have 0 for the ones column. Then we have a decimal, and then a 6 for the tenths here, a 4 for the tenths down here. These 2 decimals have a 0 in the tenths column, and then 5 in the hundredths for this decimal, and this last one here, 0.001, has a 0 in the hundredths column as well, and it has a 1 in the thousandth. So you sort of plug them in, and then we can compare them. Again, starting the far left, we have zeros in all of them in the ones column, so they're all the same in this respect. So I'd move 1 spot to the right and look for the largest digit, which is a 6. So that tells me that this first decimal, 0.6, is the largest, and then the next largest digit is a 4, so the 0.4, or 4/10ths, will be the second largest. These 2 decimals, 0.05 and 0.001, they both have a 0 in the tenths column, so they're equal up to this point. So we move on to the next place value spot, 1 spot to the right. Now there's a difference. 0.05 has a 5 in the hundredths, and 0.001 has a 0 in the hundredths. 5/100ths are larger than 0/100ths, so that means that 0.005 is larger than 0.001. So if I put them in order from greatest to least, 0.6 will be the largest, 0.4 second largest, 0.005 will be next, and the smallest will be 0.001. So if this strategy is a little bit tricky, comparing the place values and moving from left to right, 1 spot at a time, there's another way we can do it. But first, remember that if we have a fraction like this, 10/100ths, it's the same, it's equivalent to 1/10th, right? Because 0.10 is equal to 0.1. Like 10/100ths is the same as 1/10th. They're equal. So when we know that, we can see that if you just plug a 0 on here onto the end of a decimal, it doesn't actually change the value of it. So knowing that, if I plug zeros on to the end of my 4 decimals here so that they all go to the thousandth column, then it's much easier to compare them, right? So instead of 6/10ths, I just plug a couple of zeros on, so now it says 600 thousandths. Instead of 5/100ths, the original decimal, I put a 0 onto the end. Now it says 50 thousandths. This was already 1,000th, so we don't have to do anything to that. And then the last one was 4/10, so I plugged 2 zeros onto the end of it. Now it says 400 thousandths. So now we can compare them because they're all in the exact same unit. I can tell that 600 thousandths is the largest, followed by 400 thousandths, followed by 50 thousandths, and the smallest would just be 1 thousandth.